Hello, this is C4 video on binomial expansions. Now, first of all, I just want to apologise for the camera angle today. Just a bit of faff with powering the damn camera, so sort of had to do it in this view. But I don't know if you like it or prefer it. I'll try and keep to this kind of view if that is more helpful to you. I think it makes me look better anyway. Which isn't hard, but never mind. So anyway, the start of this video is going to be about binomial expansions and validity. Oh, that took a while. Basically, I'll be saying, talking about when a binomial expansion is valid, when it's not valid, and how to check and say which values it is valid between. That'll be this video, and I'll just be also at the start, which is should have started with this. I'm going to be talking about the binomial expansion and just recapping a few things about it. I mean, in C4 you generally only use one of the methods. In C2 you use the other method a bit more, but you could use either. And obviously I'll clarify which one you use and why. Sorry. And in the next video, so that I'm between two videos, well, I'll attempt to do two. I might put in another one for the past paper question. Sorry, I was just looking at the order of what's got to talk about. So in the next video, just to get you a bit of a head start, I'll be talking about the partial fractions and binomial expansions, which is a little bit more difficult, but it just carries on from what we already know. I'm assuming you do, about partial fractions, and apply it to this new theory that we're going to learn about binomial expansions. Well, again, we already know about that, but basically it's just applying all of what you know. I'm assuming you know a bit more, but anyway, we'll digress. So hopefully I've spoke a bit there and you've got an idea of what this video is going to be about. So this video, apart from that bit at the start, will hopefully be quite short. So binomial expansions, okay, so as I said, we're going to recap the two types. Okay, so first type you could, well, two ways of the binomial expansion. The one that I generally most see is going to be something like a plus b to the power n. Well, not in C3, in C4, more something you'd see in C2, and you would recognise this. So that would be one of the forms it had taken, and the other form would 1 plus a to the power n. And you're more likely going to use that one for. Check if you can see that, because I'm not sure this camera angle picks out very well. Zoom it a bit more. Yeah. So hopefully that. Sorry. Yeah, hopefully you can see that. You're most likely to be using that second expansion, and the second one is going to be something like that: a n plus n take 1 over the factorial of 2. This factorial of 2, when we say factorial of something, it's 2 times 1. But you just keep going down by 1 power and times in it. So if it's 3 factorial, it's 3 times 2 times 1, etc. Okay. So that's what that means. And then you times that by a squared, which is this number, a, and that a is going to be quite important for a lot of things. Okay. So I'm assuming, I'm not going to go into too much detail about that one, because I'm assuming, well, we don't really need to know too much about that. I'm assuming you know it from C2 anyway, so again, it's more focusing on this thing. And obviously you do that to as many expansions as it asks you to. Obviously you could only do up to a certain limit, because obviously you're going to get a point where n take something, whereas this is n take 1, it becomes n take 1, n take 2. And it obviously gets to a point where it becomes 0, so obviously you stop there, but generally you do it to however it asks you to. Just before we get on to some of the C4 stuff, just recap. I don't know if I've covered it in my C2 videos, but I can't bother checking. So basically, this is generally the form you want to see in C4, but sometimes you might get something like 3 over 2x. Well, this is sort of the hardest. 2 take x, sorry. Is that right? Yeah. this is the sort of hardest thing you'd get that you'd want to put, because generally you try and put it on that type if you could. So what this essentially saying is anything over, so if it could be 3 over 2 take x or 4 over 2 take x. If anything is over something else, so that the fraction part of the bottom of the fraction is the power of -1. So if we had just take it over the equation, 3 take 2 over 2 take x, that would be 3 times 2 take x to the power 1. -1, sorry. Because that is the negative reciprocal, essentially what it's saying. You flip the fraction of the power and change the sign. So that's essentially what it's saying. Because it's saying 3 over 2 take x to the positive 1. Or you could say 3 times 2 take x to the power of -1. They mean the same thing. So obviously that is a bit more closer to this form now than that was. Okay, so we could do something with this, but we've still got a problem here. This is 1 plus a, this is 2 take a. The plus or minus doesn't matter, it's just got to be 1, some positive or negative a. And it is 3 brackets 2 take x. Now this 3 is just, we're going to times the whole expansion, so you don't need to worry about the 3 for the moment. But this is essentially the same, so 3 times, all of this in here is the power of -1, so it's 2 to the power of -1 times minus x to the power of -1. Okay, so that's essentially what it's saying. And then we can simplify that a bit further. So if we take the 2 out of this, so I'm not going to do anything with the 2, not going to move it over yet, so we're just going to have 3 and then do the square brackets again. 2 times, now because we're taking 2 out of that equation, now we're creating another bracket. So 2 times something is 2, 2 times 1 is 2, so that's 1, and 2 times something is minus x, so that's minus x over 2. I'm probably saying it in a complicated way, but and again, all of that is still to the power of -1, because all we've done is put it in a bracket there. And now there's 2, so it's 3 times 2 to the -1 times 1 plus x over 2 to the power of -1. So 1 take x over 2 to the power of -1. Okay, so 3 times 2 to the power of -1 is, as we said here, this is the same as doing 3 over 2 take x, and that's the same as 3 times 2x to the -1. And because we're doing 3 times 2 to the power of -1, we could simply do 3 over 2. Now you could write 1.5, but it'll be a bit more confusing if you do it that way. So obviously we've taken 2 out here, and then that just becomes 3 over 2 times 1 take x over 2 to the power of -1. Okay, and then you would expand that as you normally do. Alright, but this validility, so hopefully that, basically what I was doing in that section there is I was just recapping some C2 knowledge, so none of that should be new, I don't think. Maybe the -1 is just incorporating a bit of C1 and C2 together, which you might not have done before, but you should have known the skills to do that anyway, is what I'm trying to say. So, as I said, hopefully that makes some kind of sense. We're going to step that up a bit. We're going to edit that into sort of C4 territory now. Okay, so we've got it in the form we want to do, but how can we know if it's valid or not? Well, hopefully this little cloth thing works, yeah. So hopefully you've copied that down. If you haven't, you just go back a step in a section in the video and just pause it and then write it down. But again, as I said, that shouldn't have been anything you need to worry about. Well, you do need to worry about it, but I meant that in the sense is hopefully you should come familiar, and yeah, that's not the main part of the C4 stuff you're going to get asked on. It's just something you're expected to know. Okay, so we said that 3 over 2 take x, and if we simplified that, that was the same as saying 3 over 2 1 take x over 2 to the power of -1. And again, if you don't know how we did that, just go back a few seconds in the video and I did explain how to do that for those of you who just don't pay attention, which is fine. Just means you're not going to do well in life and die a horrible death, but never mind. So that's what we said. Okay, so how do we know if that's valid or not? Well, there's a little statement here that you need to know. I'll write it down on the board and I'll put it in sort of the side thing, leave it at the top, so again, for them lazy people, you can just note it down whenever you can be bothered to. And the statement is, if n, so basically if this power here, if n, I'm going to call that n, so this 3 over 2, 1, take a to the power n, and it's saying if this n here, so basically in the binomial expansion, if the bracket power is not a positive, is not equal to a positive integer, so if it's not a positive integer, basically what we mean by that is we're saying, well positive bit should be fairly self-explanatory, I think, logic. Sorry, but the integer just means a whole number, so it could be a positive fraction. It could be basically if n is either a positive fraction or a negative fraction, then the range of x, or the range of a, so the range of that bit there, the range of a is between -1 and +1. Now I'm going to do the range for this one. So if we get a question that says, so somehow weirdly, magically, we've just worked this out, and this exam comes up on this question comes up on this year's exam, and it says, state the values of x for which that equation is valid. Now, I don't think that's it's a little bit easy. That's maybe a 1 or 2 mark question. It's not something you're going to get strenuously asked. It might be a 3 or 4 mark question if it's not given to you in that form, which it most likely won't be. So basically it gathers the thick people to make a few more mistakes and you to get the extra marks so it can separate you. So anyway, unless you want to thick people. But what I'm trying to say is they may not give it to you in this form. So hopefully you would have been able to work that out as you would normally did in that previous little bit there. So again, the question's asking us, say, what values of x or a is this equation valid for? So we said if n is not a positive integer, so if it's either a positive fraction, a negative whole number, or a negative fraction, the value of this x bit, or x over 2 or a, is between -1 and +1. And you can't just say, oh yeah, well it's minus. Because it's minus, we just simply rewrite out this equation. No, because what that is a over 2, it's not just a. So what we need to do is we rewrite this equation in with our a value. So basically our a value is not just a, it's x over 2. So -1, x over 2, +1. And a few people would just leave it there and go, oh, we solved it. I mean, we put it into the equation. It's not a, we just rearrange a, put it in there. What more would they want? Well, as this says, it's a, and they want a, assuming they do. So what we have to do is times the whole equation by 2, so it's -2, x, +2. There's +1 there. And then that is your final range. Obviously you could write -2, -1, 0, 1 and 2, but it's not asking for that. That's a fairly easy way of doing it, and you're less likely to make a mistake doing it that way. Hopefully those you can count, you won't do, but just in case you can't, that's an easy way of doing it. Okay, so hopefully that seems quite self-explanatory there. One thing, again, I don't think I really need to know this, really need to explain this, hopefully you do know this, but sometimes, lost my train of thought there. I'll come back to me when I've put the video online. Oh yeah, that was it. So basically, as I said, it just slipped my mind. You might not get, I can't believe it just slipped my mind again. Oh my god, this is a bad day. Yeah, I put it on the video, if I remember what it was. But one more thing, if you've got a negative value, and you say your value of a is negative x over 2, you times it by 2 and then you divide it by negative 1. And when you're dividing a negative number, you flip the signs of the inequality. And then what you'd always do is always put the lowest value of your range on your left hand side of your inequality. I think that was actually what I forgot to say. So that's about it. I don't think there's much more to that than binomial expansions than that. As I said, in the next video we'll be mixing this with partial fractions. Basically what we'll be doing in there is they'll give you up to a value of a certain range of x, split it into a partial fraction, and then turn that partial fractions, just as we've done there with the -1 thing, where it's over it and you do it to that, what's the bottom denominator with a fraction to power of -1, and we just split it up into fractions and do the same sort of thing. I don't want to tell you too much about it because I don't want to give too much away, as we're just ending this video and I don't want to confuse you. So just to recap what we've done today, basically we discussed the two types of, well, I just mentioned there was two types. Binomial expansion only concentrated on the one that you most likely get asked in C4 on, and how to put it into that form when you're not given it in that form. And then we went on to discuss how you discuss the validility. I said it right there. And we just said if n is not positive integer, so if it's a negative number or a positive number that isn't a whole number or a negative fraction, then a is between -1 and +1, and you rearranged a as the x over 2 or x value, and then you would simply simplify the equation. So if it was x over 2, you times both the sides by 2 to get a, and then you would leave it as that. And that was about it, to be honest. As I said, in the next video we'll be doing partial fractions, but it's nothing too strenuous, just mixing what we already know. So we'll see you in the next video.